Well, this is Jack Jackson back again. In our previous video, we looked at t-distribution properties, and this we're going to look at how we can use our TI calculators to do some t-distribution probability and inverse probability calculations. So let's first do this. Let's graph a t-distribution PDF with 5 degrees of freedom on your graphing calculator and use the graph to compute the probability that this t value, your x value, I'll call it t in this case, this t value is between -2 and 1 for this particular one, and shade the corresponding area under the PDF graph. Well, this is not too hard to do. Basically, we can do it. It works very similar to the way we did stuff with normals. So to graph it, we just graph t PDF x5, put that in the y1, pick appropriate window. There's one that will work. And then we do calc 7 to get our area shader approximator, right? And then I put in my lower limit, which is -2, my upper limit, which is 1, and then boom, there it shades it and comes up with the probability, which is that area, 0.767. Okay, about almost 77%. Okay, now that we had to put in the PDF and use the Math Calc 7 to get it to work. But there is a shortcut to this. So one shortcut is, without even typing in the formula, it's not even necessary. You can start with just completely blank ny equals. This will work. Go to distribution and draw. So go to distribution, remember, is second variables. But right arrow to draw and pick number 2, shade t. It's going to ask you for a lower and upper and degrees of freedom. Give it the -2, the 1, degrees of freedom 5. Click on draw, and it draws it here. It's basically the same picture we see here. Looks like I probably got a slightly different window than I had up here, but basically the same. But this one tells you the area, which is what that one told you. It also tells you the degrees of freedom and the lower and upper. So it tells you a little bit more information on the screen than the other one did. And it does it in such a way, it picks, if you need to have to pick a decent window for this, either way you do it here. But it does have a nice little shade t, works just like the shade norm did that we looked at earlier. Okay. And by the way, notice when we get to it, the shade chi-square and shade f exist as well. Now, if you want to shade it on a TI Nspire, it doesn't have the shade t, at least as far as I know. But you can do a t PDF here and graph it, and then you can do go to menu, analyze graph, and then integral, and then give it the lower and the upper here, which were -2 for this one and 1 for this one, and it'll shade it and compute the probability, compute that area, which is the probability there. So we can do that. Okay, so now how can we figure out from this, from the home screen, what the probability is? Well, we just do, if we've got this formula in as y1, we can just integrate it from -2 to 1, the t PDF x5 dx, or since it's stored in y1 already, -2 to 1 y1 dx. The older operating system looks like the middle screen here, which is exactly the same thing. And that's the same thing we got by doing the shading here, or the draw shade t here. So either way you do it, you get the same number. The Nspire works pretty much like what you see on this last screen here. So now, how can we use the built-in CDF function to compute the probability? Okay, and then how can we graph the CDF? So we could actually graph the CDF and the TPDF together. Here I have a TPDF from x5 and TCDF -1000 x5. And actually I turned off the y1, I think, before I drew this graph, because on this picture I only see the CDF graphed. And I can do a trace here and say trace 1, and it gives you 0.818, that's going to be the y1 of 1, the probability that x is less than 1. And then right there is the point. So the probability to the left of that is the y value here, which is the distance from that point straight down to the x-axis. And then if I plug in a -2 in a trace, I get 0.05. That's below this point right here. That's the y value of that point on the CDF, which is below. And you want to subtract those two, the 8.18 something minus the 0.05 something. Subtract those two, and that gives you the probability. Now you can also do that from the home screen then as just y1, y2, I've got it in y2 is the CDF, so y2 of 1 minus y2 of -2. That'll give it to you. Or the best way, and this is the way I would do it, is this right here. There's a shortcut which is just TCDF, and just do TCDF from lower to upper and then give it degrees of freedom, and the whole thing comes out. So that one in the middle is the best way to do it. So we can do it from the PDF here on the Inspire with the integral, which is summing up our probability from -2 to 1, the TPDF, x, 5 dx, there, that gives it to us. But the better way to do it is to use the CDF. So just use TCDF, lower, upper, and the degrees of freedom. So basically this last version here on the Inspire, or this version in the middle, boxed in red on the TI-84, is exactly how I would find the probabilities. And I probably wouldn't even bother drawing them out, but if you need to, you can. Use the graph of the TCDF function with 5 degrees of freedom to find B, where the probability that T is less than B is 0.72. Well, if you remember working with a CDF, once we got the CDF graph, which is what I have here in Y2, I just turned off Y1 for the moment. You put in the probability to the left, which is what they've given us, 0.72, as Y3, you have a horizontal line and calculate the intersection, and the x value there is the value of B that we're looking for. So if x is less than this particular value of B, 0.62398259, probably we would round off somewhere less than that at some point. And the probability that x is less than, or T is less than that, is the 0.72. Now, if, for example, you do not find the inverse T on your calculator, some of the older TI-83s, maybe even some of the older 84s, but I think the newer ones, I think maybe all the 84s, or at least the newer ones, have an inverse T. But some of the older 83s may not have an inverse T. So if that's the case, this is going to be how you're going to work it out. But if you have the inverse T built in, just like the inverse norm, it's even easier to work. This is by far the best way to do it. So you just type in inverse T, give it the probability to the left, the degrees of freedom, and out pops your answer. All that stuff is sort of built in the background for us. Very nice function built in. Same way for the Inspire, it's just an inverse T, give it the probability to the left, and 5. Remember that this probably has to be to the left, a less than probability. All right, so I have a 7 problems here now that we're going to use your TI-84 or Inspire calculator, similar calculator, to compute the following. We have a couple of between probabilities with different degrees of freedom, different numbers. We've got a left tail probability, right tail probability, and then we got 3 different kinds of inverse probability problems. So let's take these one at a time. At this point, you should be able to do these as exercises. So this is going to give you some practice. So be sure you have your calculator out and be sure you work these yourselves. And as you work it yourself, then when you think, you pause if you need to work it out, and then advance the video, press play, and then check your answer as we go. So let's do these one at a time. Okay, do this first one here. The probability that -1.2 is less than T, which is less than 1.7, for a T distribution with 8 degrees of freedom. Press pause and then figure this out. Well, here it is. If we're doing probabilities, just like in normal, all we really needed to make the probabilities, we didn't have to draw anything. So all we really needed to find the numbers is we needed a normal CDF for probabilities, we needed an inverse norm for inverse probabilities, and you got the same thing for the t. You got a t-CDF for probabilities, you got an inverse t for inverse probabilities. So that's what we're going to do here. So this is just t-CDF, and the syntax is lower, upper, and then degrees of freedom. In fact, if you have the newest operating system, it may actually come up with a window where you can put that in. Let me show you actually this one here. So I can go to second distribution, do number 6, and it comes up with this window. I want to put negative 1.2 in there, and I want to go up to 1.7, and I have 8 degrees of freedom, and then I'm going to hit paste and hit enter, and there it is. This is exactly the same screen I have here. So it's pretty easy. On the Inspire, let me clear that out. Okay, so it's under Menu, Probability, Distributions. There's your t-CDF. Lower bound is negative 1.2. Upper bound is 1.7. Degrees of freedom is 8. Okay, and there it is. There's the probability. Same thing that we had a while ago. Okay, well, same kind of problem here. Do this one for me as well. Probability that negative 2.7 is less than t, which is less than 3.5 for a t distribution with 11 degrees of freedom. Press pause, come back when you have an answer. Now, it's important that you do these on your own and practice this. Make sure you're really good at pushing the buttons on the calculator and getting the right things here. So a lot of what we're doing in this class is, calculator wizardry. We're learning how to push the right buttons on the calculator to get it to tell us what we want, and our job really is to figure out which buttons to push, what to put in, and then how to interpret our answer that it gives it out. The calculator is going to do most of the grunt work for us. So t-CDF, negative 2.7 to 3.5 with 11 degrees of freedom looks like that on the TI-84. So it's about 98.7% is the answer. All right, how about this one? Probability that t is less than negative 3.2 with 19 degrees of freedom. Okay, work this out. Well, this one you're going to need negative infinity because it's a left-tailed, but you can't put in negative infinity, so I just used a negative 1,000. That's plenty small enough. So t-CDF negative 1,000, negative 3.2, 19. And this works out. So 0.002357. How about a right-tail probability? Probability that t is greater than 3.5 with 9 degrees of freedom, t distribution. Press pause, get an answer, come back and check it. Well, we just go from 3.5 up to infinity. Well, I'll use 1,000 instead of infinity. That'll be fine. And then 9 for the degrees of freedom. There we go for an answer. All right, how about an inverse probability now? The probability that t is less than b is 0.95 for a t distribution with 18 degrees of freedom. What's b? Again, pause, work it out, come back. Well, an inverse probability is just an inverse t since it's a t distribution. The numbers you put in are the probability to the left, which is what was given in this case, 0.95, and then the degrees of freedom. And so the answer is 1.734. So the probability that x is to the left of 1.734 is 95%. All right, how about this one? Probability that t is greater than b is 0.9 for t distribution with 14 degrees of freedom, 5b. Now this time, remember that the input of an inverse t, like the input for an inverse normal, is the area or probability to the left. So if 0.9 is the probability on the right, then the complementary probability on the left is 1 minus 0.9, which is 0.10. and then when you work that out, you get this. So in this case, the t value we're looking for is negative 1.345. Okay, what about this one? The probability that t is between negative b and b is 0.90 for a t distribution with 4 degrees of freedom. Find b. Now here we're going to have to leverage the symmetry to our advantage a little bit. And remember that b, it's centered on the mean of 0. So if you're going b to the right and b to the left of that, you're doing a region that's symmetric about the mean, which is 0. Okay, so if you do this, there's 0.9 between b and negative b. Okay, that means what's left on the outside of that is 0.1 in the two tails. But each of those two tails has the same amount, so half of that, which is 0.05, is in the left tail and the right tail. So the probability that you get something to the left of b is the 0.9 plus that left tail of 0.05, which is 0.95. So altogether, there's 0.95 to the left of b. So the probability that x is less than b is 0.95, or the area under the CDF, the area under the PDF to the left of b is 0.95. So that's what we put in for our inverse t. Inverse t of 0.95, comma 4, and you get about 2.13. Now, you could do all this same thing on Inspire, and here you see the answers to all of them work out, the same problems that we just did, all worked out on a TI Inspire, and they're just math probability distributions. Pick TCDF or T inverse T, whether you're doing a probability or an inverse probability, respectively. And so now you can see the syntax there for all of those problems on the TI Inspire. So now, in the last video, we did some things about T properties. In this one, we did some T distribution calculations. If you notice, basically it works just exactly like the normal calculations did. TCDF to find probabilities, inverse T to find inverse probabilities. We'll come back to using these a lot more in inferential statistics a little bit later on down the line.